Alright, moving on to our second day of properties of logarithms. Reviewing what we talked about yesterday is when we expand. So think about expanding is a word that makes it bigger. So we're going to go from one little piece to multiple pieces. And when we expand, we look at the fact that we have log base 3 of 5x. 5 times x means we're multiplying, which means we're going to separate our pieces with an addition sign. Since I've got log base 3 is going to be present in both of our pieces. You're always going to have that same base, and that's going to be log base 3 of 5 plus log base 3 of x. Our second property, we've got log base 2 of x squared. When we have an exponent, that exponent gets brought out front. So this is 2 times the log base 2 of x. And if we have division, so I still have log base 5 is going to be present in both pieces. Since I'm dividing, that means I'm subtracting those two pieces. And the 6 minus the x. I look at 6. 6 cannot be broken down anyway. I can't bring it to any power. And x cannot be broken down, so that's going to be my answer. The opposite of expanding something is condensing it. So when you're condensing, you're making it smaller. So we're going to do everything we just did in reverse. So we're going to start with our answer, and we're going to work backwards to what our answer what we used to start with. When you condense, note that when you write the logarithm or the natural log, you're only going to write it once, and it must have the same base in order to combine them. So when I look at number 1, it's log base 3 of 5x. I don't have log base 3 of 5 times log base 3 of x. You're only going to have that log base or that natural log one time in your answer. So we've got log base 5 of 7 minus log base 5 of x. Since I'm subtracting, that means that originally I was dividing. I've got log base 5, so I'm going to have that in my answer one time. Since it's 7 minus x, that means that it was 7 divided by x. We look at number 2. If I've got 2 times log of x, anytime there's a number out front, the only way that number out front gets there is if it was an exponent. So this is really log of x squared plus log of 5. And when we look at the addition sign, that means that I had multiplication. So I've got log, and that's only going to be written once in my answer, and that's x squared times 5. And you know that when you write it, the coefficient goes first, so that's 5x squared. And hopefully you remember your rules, so even though this is not written, that's log base 10. That's your common log. Number 3, we've got 3 natural log of x plus 5 natural log of y. The only way that number gets out front there is if it was an exponent, so this is really the natural log of x cubed plus the natural log of y to the 5th power. And again, we look at that symbol of addition means that we are multiplying. Natural log, and then I've got x cubed times y to the 5th. Next one, natural log of 20 plus 2 natural log of 1/2 plus natural log of x. So I look at natural log of 20, nothing is changing there. That number out front is my exponent, so that's a natural log of 1/2 squared plus the natural log of x. Remember, we're condensing, so we're trying to put things together. We want to have one piece in the end. Each of my pieces have natural log, so I'm going to write that natural log one time. This addition sign means I'm multiplying, and this addition sign means I'm multiplying. So all pieces are going to be multiplied together. So I've got 20 times 1/2 squared is 1/4 times x. So then I simplify this. I combine like terms. 20 times 1/4 gives me 5x. So the answer is the natural log of 5x. Number 5, we've got log of 5 times 8 minus log of 5 of 12. Our subtraction sign means that we are going to divide. We're going to have log base 5 one time in our answer, and that means that we've got 8 minus 12 is 8 divided by 12. Just make sure that you treat it like any other normal fraction. You always want to reduce. Don't leave it as 8 over 12. Reduce your fraction down to 2/3. Number 6, we've got 1 plus log of 3x minus 2 log 3 of y. Notice that we've got a 1 there. And we talked about yesterday that sometimes everything cancels out. And that's how we get numbers without the log bases. So what I'm going to do is I'm going to kind of work backwards. Just like if you had 1 and you wanted to make it into a fraction and all of your denominators were 5, you would change that into 5. Here, all my other logs are log base 3s. So I'm going to change this into the log base 3. And the only way that would have been able to cancel out is if it was log base 3 of 3. So I'm going to replace the 1 with an equivalent measure. Remember, we're working backwards. Before, I would have started here and gone to 1. Here, I take the 1 and I turn it to the log base 3 of 3. And that's plus log base 3 of x minus, we've got our number out front, so that's log base 3 of y squared. Now we're going to combine our pieces together, all of them having the log base 3. This means our plus sign means we're going to multiply. So we're multiplying 3 times x, and then this means that we are dividing. So it's 3 times x divided by y squared. And you're going to make sure that you go in order, so it's 3 times x, and then you're going to divide everything by y squared. Almost done. Alright, now moving on to evaluating with your calculator. And if you remember from a few days ago, we talked about in your calculator you can only enter in the natural log or the common log. And then common log has a base of 10. So let's look at our calculators. And remember, here's your log button on the left. And right underneath that is your natural log button. So what we want to do now is we're going to evaluate the log of 4 times 7. And we need to have a log of 10, a base 10, in order for it to go in our calculator. So we can't enter this as is into our calculator. So what we're going to use is our change of base formula. And the change of base formula says if you have a log base b of u, that's the same thing as log of u divided by log of b. And when you rewrite it this way, it's log base 10 of u divided by log base 10 of b. And this way we can enter it into our calculator. So this really becomes log base 7 divided by log base 4. It's always this number divided by the base number. So in our calculator, we hit our log of 7. Make sure that you close that out in your calculator. You don't want to divide a log inside. So you're only taking the log of 7 on top divided by the log of 4. And that's going to give us about 1.404. Number 2, we've got log base 2 of 6. So when we rewrite that, it becomes log of 6 divided by log of 2. Now it's really, 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 really important that you do not try to simplify this. Log base 6 divided by log base 2 does not equal log base 3. This is not true, so do not do that. Just enter what you see into your calculator. So we've got log of 6 divided by log of 2. Hit enter, and we get that. That is about 2.584. 5 when we round to the nearest thousands position. And if you don't believe me, if we enter in log of 3, notice that you don't get the same answer. So just be really careful that you're not simplifying numbers that can't be simplified. And that's it for today.